Hey, what's going on? This is Samaj Richardson, and you are watching an Engineering Student HQ video. So, what I'm about to do in this video is show you how, if you're given a certain number of properties for a substance, how to find the missing properties. So, here we have water, and we're given the pressure 500 psi and the specific volume, which is 0.650 cubic feet per pound of mass, and we're trying to find the temperature, enthalpy, the quality here, X, and then the state of the water. So the first thing that I always do, well, obviously we're going to need here property tables, which you'll find in the back of whatever thermodynamics book that you have. So the first thing I always do is I always go to the saturated table first. That's just an assumption that I make. So since we have pressure already given to us, we're going to go to the pressure table, which is A5. So let me go down there. Okay, now we're going to look up our pressure. It's 500. So, and then the temperature is going to be in the second column here. So whatever temperature that gives us, which is right here, it's 467.4 degrees Fahrenheit. So, where can I put that? Put that right here. T equals 467.04. Okay. Now the next thing that we want to do is we're going to look also at the specific volume for the liquid and the specific volume for the vapor portion, because it's a saturated, we're assuming that it's a saturated mixture, so that means that there's a liquid portion and a vapor portion. And just to make sure that I'm looking at the right thing, let me zoom up a little bit. Okay, so yep, saturated liquid here, third column, saturated vapor in this fourth column. So we're going to go back down to 500, which is right here, and I'll highlight it. So this is VF and then VG. And let me get back to where I'm supposed to be. And then I'll put these values in. Okay. 0.0195, 0.01975. And then 0.92819. 0.92819. Okay. Now, after that, we're trying to find the quality, but we don't. So what we're going to do is we're going to use this VF and this VG to help us find the quality, because there's a formula that we can use that is going to help, which goes like, oh, I forgot to put that in. 1 second. We already know what this is, so let me put that. Okay. So, as I was saying before, okay, we know this here, specific volume equals VF plus the quality times V was Vg minus Vf minus Vl. So, knowing this, we can just rearrange it, solve for x, which goes like this here. So x equals specific volume minus saturated liquid specific volume over saturated vapor specific volume minus saturated liquid specific volume. And that is, wow, it takes a long time to write this out. Okay. So that is what we have here, 0.650 minus 0.01975 there, and then over 0.92819 minus 0.01975. Okay. And this is going to give us an answer of, I have it written down somewhere. Oh, 0.693. So that is our quality. And this right here, this 0.693 verifies that it is in the saturated state. Because we're trying to find the state. I assumed that it was saturated liquid because that's just my first assumption in the first place. But now I know for sure that it's saturated because the quality is not 0 and it's not 1. If it was 0, it would be a compressed liquid. If it was 1, it would be a vapor, saturated vapor. So, since it's 0.693, it's a mixture of the two. Okay, so that's right. So now we know the temperature. We also know the quality. We now have to find, and we know the state. So now we just have to find the enthalpy. So, the last step for that, okay, the equation for enthalpy looks like this. Enthalpy equals, okay, that's an F. No, that's messed up. Plus X and then H F G. So simple. You just go back to the table here, and now we're going to look up the enthalpy, and it's a little bit hard to keep up with these things here because I have to scroll down so far and it's hard to keep it aligned. Okay, but we're over here and we're just going to go to where it says what was our pressure, 500, and then in these two columns is where we'll find our information right here. So I'm going to go back, plug that information in. So 449.51, and then the next one is going to be 755.48. And just plug those numbers in here. So let's see. H equals 449.51 plus 0.693 and this will give you 973.05 kilojoules per kilogram. And that's how you do that. So now we know I messed that up. But anyway, so if you're given water with and you're given the pressure, you're given specific volume, and now you have to find all of these other properties, that's how you'll find that. I'll do another example in a different video because this one took a lot longer than I thought. But I'll do another example for superheated water, and then I'll also do another video for finding properties of water in a compressed liquid state as well. So yeah, that's it for this video. Hopefully you find it helpful. If you have any questions, need any clarification, just hit me up in the comment section and I'll get back to you.